So here we're told that a circuit has been connected for several seconds. When you hear several seconds, it means that any capacitor is fully charged. We're then asked to find the current in the 4-volt battery, 3 ohm resistor, 8-volt battery, and 3-volt battery. Let's look at those batteries and resistors. So we're asked to figure out, okay, what is the current through 4, which is here, through 3 ohm, which is here, through 8-volt battery, which is here, and through the 3-volt battery, which is here. Now, the first thing we need to notice is that this capacitor here is fully charged. That means there is no flow along this wire here. So that means the current through the 3-volt battery is equal to 0. So we've already answered D here. What it also means is that we can essentially just remove this entire section from the circuit because we know the current there is 0. So now what we want to see is, well, okay, if we have I3 going this way and coming this way, this means this is I3. It also means that this is I2, and it means that this is I1. So we're essentially asked to figure out I1, I2, and I3. To do that, we're going to use both Kirchhoff's loop rule and junction rule. So let's start off with the loop rule. And we can only make 2 loops here. Like this loop is not going to give us any information. So we're going to use this loop and we're going to use this loop. And then we notice here that this junction combines I1, I2, and I3. So we're going to use that to figure out what I1, I2, and I3 are. Our first loop is going to be this one here. Starts like this, and it goes like this. Now, the interesting thing about this loop is that here, the current's going one way, right? But we're saying that we're going the other way. And what's going to happen is that we're going to have to add another negative sign when talking about this delta V. Now, this is loop 1. Loop 2 is going to be this loop. So we start here, and we flow like this. This is loop 2. So loop 1, we have 8 volts, right here. This is 8 volts. And then we have negative, normally we'd have negative I2, R2. But here, because we're going in the opposite direction of I2, it's negative, negative. So it's plus I2, R2. And then it's going to be negative here. I shouldn't call it R2, actually. I should just say what it is. So what I meant is 3 ohms minus 5 ohms times I1. And now loop 2 is going to be equal to, we have 4 volts minus I3 times 3 ohms minus, and then we have I3 times 5 ohms. Actually, I think, sorry, I made a mistake. This is, here we have I2 going this way, and then we have I3 going this way. So minus I2, 3 ohms, minus I3, 5 ohms. And these are both equal to 0. Now we have 3 unknowns, right? We don't know this, or this. So we have 3 unknowns and we have 2 equations. That's going to be a bit of a problem until we use our junction rule right here. And we say that I1 plus I2 going in is equal to I3 going out. I1 plus I2 is equal to I3. So now we have 3 equations and we have 3 unknowns, so we can start solving for things. So what we're going to do with loop 1 is solve for I1, and we see that I1 is equal to 8 volts plus 3 ohm I2 divided by, I'll just move these down, divided by 5 ohms, and that's going to be equal to 1.6 amps plus 0.6 times I2. All right, so then similar thing for the second loop. We are going to have I3 is equal to 0.8 amps minus 0.6 I2. So we just solved for I1 and I3, and now we also have this expression here. So now what we can do is figure out, well, what is I2? So here we have I2 is equal to I3 minus I1. all we have to do is plug in what we know for I3 and I1. That means I2 is equal to 0.8 amps minus 0.6 I2 minus I1 is 1.6 amps plus 0.6 I2. Right, so now we have I2 is equal to, we have 0.8 amps minus 1.6 amps minus 0.6 I2 minus 0.6 I2. So then we have this negative 0.8 amps minus 1.2 I2. So we have I2 plus 1.2 I2 is equal to negative 0.8 amps. So of course we add these up together and we get 2.2 times I2 is equal to negative 0.8 amps, which leaves us with I2 is equal to negative 0.3636 amps. So this is I2. Now we can go back and look at I2. So originally we thought that the current flowed like this. Turns out the current is actually flowing downwards here, and that's what the negative sign is telling us. It's telling us that, hey, you were wrong. It's not going like this. It's actually going like this. So that's I2. And now we can figure out what I3 is. So we know that I3 is equal to 0.8 amps minus 0.6 times I2. So that's going to be 0.8 amps minus 0.6 times negative 0.3636 amps. And that's giving us 1.02 amps. Now I1 is equal to, let's just go back to what it was up here. We saw I1 is equal to 1.6 plus 0.6 I2. And that's just going to be the same thing here. And here for I1, we get 1.38 amps. All right, so then we know what I1 is, we know what I3 is, and we know what I2 is. To answer our question properly though, we need to go back here and say, okay, well, A said, what is the current in the 4-volt battery? So A, I want to know what was the current here. The current here is I3, and we found that I3 was 1.02 amps. And where is it going? Well, it's going where we thought it was going, right? So we have the number here, and originally we drew the line going like this. So that's right, and it's going down. Now B is, what is the current in the 3 ohm resistor? Where's the 3 ohm resistor? It's right here. So when we drew it, we thought it was going up like this. We thought I2 was going up. And then we look at our number and we say, well, we were wrong. It's actually going down. So the answer is 0.3636 amps, and it is going down. Now C said, what is the current through the 8-volt battery? 8-volt battery is here. We drew it this way, and we said that that was I1. And we got I1 is equal to 1.38 amps. And we were right with the direction because we don't have a negative sign. So that means it is, in fact, going up. Now D said, what is the current through the 3-volt battery? We already know that that is 0. Now, lastly, E says, find the charge on the capacitor. So to find the charge on the capacitor, we need to use our loop rule one more time. We're going to have this loop going like this, where we have 8 volts, 3 volts, and then a drop due to this capacitor here. So what we're going to have is 3 volts, so 8 volts plus 3 volts minus Q divided by 6 microfarads, and that is equal to 0. So now we know that this is 11 volts minus Q divided by 6 microfarad is equal to 0. Go onto the other side. 11 volts is equal to Q divided by 6 microfarads, which means that Q is equal to 6 microfarads times 11 volts. And what we see is that Q is equal to 66.0 microcoulombs. And that is it for this problem.